Hello, my name is Jamal and I'm a data scientist. I'm here to present my project, Predicting the Number of Traffic Accident Injuries in Chicago. The purpose of this project is to create a web app that emergency services can use to predict the number of people injured in a traffic accident, hopefully to then dispatch the appropriate level of services. The data comes from the City of Chicago's data sets, crashes and people. Initially, I separated the two data sets. I'm going to first train my models on the crashes data set and then add features from the people's data set, determine their impact on performance, and determine whether or not to keep them or discard them. I did limit both data sets to features that are easily reportable to emergency services. For my exploratory data analysis, I determined that I have an imbalance of data. Most crashes result in 0 injuries, and crashes that do have injuries tend to only have 1 person injured. This imbalance of data is going to have to be considered in my prediction phase. So in terms of predicting, I originally considered 4 types of models: a linear regression model, a random forest model, a gradient boosted model, as well as a custom ensemble model that would first categorize an accident as either injury or not injury, and then use a regression model trained on injury-only data to determine the number of people injured. Before developing the full custom ensemble model, I decided to train the 3 regression models on injury-only data, assess the performance, and determine if it's wise to proceed with the full ensemble model. I decided to use the root mean squared error metric as a way to determine the effectiveness of my models because it's a measure of how far off the model is on average. My training results displayed here show that training the regression models on injury-only data degrades performance. Therefore, I am not going to proceed with the full ensemble method model. Adding the people's data set has a negligible impact on performance. Therefore, I'm going to exclude those as well. And so I am stuck with in my final model using the crashes data set, and I'm going to examine the gradient boosted regression as well as the linear regression models because they have the best performance. Ultimately, I decided to use the linear regression model because even though it has a slightly worse RMSE score, it does have quicker prediction time, which is better for the app, and it does have a lower training time, which means I can fine tune it quicker. My final model is the product of cross validation, and I developed a lasso regression model that has a slightly better RMSE score, but the same prediction time. The web app I developed is here, and it has 3 pages: a home page, a prediction page, and a results page. Click Get Started to go to the prediction page, and here's where you'll input your data, and it's either going to be a drop-down menu or an input field. Over here, I already have a form that is already filled out, and then you just hit the submit button. And then on the results page, it's going to show you the number of people that are predicted to be injured, as well as returning the values that you inputted. Thank you very much for watching my presentation. The full details of this project are available on my GitHub repo. Thank you.